temperature difference. This is in Unit 1 of Force Thermal Systems. Now, temperature, if you remember, we have mainly two scales that we use. We use Celsius and we use Fahrenheit. And remember, it's based on water. And water boils in the Celsius, it boils at 100, and in the Fahrenheit, it boils at the 212. Water freezes at 0 in the Celsius and 32 degrees in the Fahrenheit. It's important to keep that in mind because we're going to be talking about the difference in the two. Now, if you remember, we had talked before about how Fahrenheit, that was the original temperature scale. And people could not remember this 212. We remember the 32 because we use that in the wintertime. You know, is the bridge going to be icy, you know, or not? Well, we know because of the temperature, you know, if it's 50 degrees, we don't usually have to worry about the bridge being icy. But if it's 32 or 31, yes, we have to be careful. Even if it's 33, because the wind blowing through a bridge area actually cools it, and it doesn't really have to be 32. It could even be 33, but it might be colder because of the air blowing through that region. But we're more familiar with the Fahrenheit at 32, but not the boiling. So remember what happened is they said, oh, there's got to be a better way. And so they decided that, okay, let's just have a temperature scale that's based, you know, up to 100. 100 is boiling and 0 is freezing. And then they just made graduations in between, which we'll come back to that. Now, just a reminder too, temperature, it's a measurement. You read a thermometer. Okay, so let's say in your house, your thermometer for your home reads 68 degrees Fahrenheit. All right, we're going to call that our initial temperature. All right, you're cold, you want to raise the temperature, so you turn the thermostat up so that it says 72 degrees Fahrenheit. That's going to be your TF. So what's going to happen if you have a furnace, your furnace is going to kick on, all right, because you're going to have a temperature difference here. That's what you're creating. All right, you're going to have warmer air blowing out of your vents. All right, and then you're going to have an increase in temperature or a temperature difference. All right, now the temperature difference, what we do, this little sign here, remember that little triangle? That is a delta. That's a Greek letter. And when you see that used in math and science, it means that you're going to subtract something. So we normally subtract final temperature, that means the last one, minus the initial. So if we want to find the temperature difference for, you know, our room, okay, 72 degrees Fahrenheit minus 68 degrees Fahrenheit, subtract those two, and you get 4 Fahrenheit degrees. Now what I want you to notice is something here. Look at the degrees. All right, this is not a typo. All right, notice that the degree symbol is after the Fahrenheit. All right, when you see this here, that means that there is a temperature difference. That means that you've already subtracted 2 temperatures. Okay, when you hear the term graduation, that means the spaces in between, all right, for each of the degrees that are marked on a thermometer. All right, and one of the things that's important to note is that if you compare the Fahrenheit and the Celsius, you're going to find out that the Celsius are 1.8 times larger than on the Fahrenheit thermometer. Now, why would anybody care? Because what we're going to be looking at is converting from Celsius to Fahrenheit when we have a temperature difference. You know, last time we talked about converting when we have, you know, for temperatures, like you see at, you know, on the bank marquees where they have the temperatures. All right, but this time we're looking at converting when there is a temperature difference. All right, so we talked about how to find the temperature difference by subtracting them. All right, when you find temperature difference, you're going to find that that degree symbol is going to be to the right of the Fahrenheit or the Celsius. Okay, so what's going to happen, these are your equations. Whatever you have in Fahrenheit degrees and you need to convert to Celsius degrees, you're going to use this here. This is a ratio. 1 Celsius degree is equal to 1.8 Fahrenheit degrees. Because they're equal, you can put them in a fraction form, because this means that this thing right here is equal to 1. All right, these things are equal. Okay, now how do you know what to put on the top and what to put on the bottom? If you are starting with Fahrenheit degrees, then Fahrenheit degrees goes on the bottom, that 1.8. All right, another way of looking at it, if this helps, whichever way helps, if you want to end up with Fahrenheit degrees or Celsius degrees, then that has to go on top. Okay, so here, if I have Celsius degrees, all right, notice here, Fahrenheit degrees is going to be on top. It's going to be the opposite of what you have there, so that I end up with Fahrenheit degrees. So let's take a look at an example. I have 45 Fahrenheit degrees. All right, look at my ratio here. Fahrenheit's going to go on the bottom, so it cancels out. Celsius degrees is going on top, so I end up with that. So what am I going to do mathematically? I'm going to take 45, divide it by 1.8, and I get 25. So my answer is 25 Celsius degrees. What if I want to do the reverse? What if I want to go from Celsius degrees to Fahrenheit degrees? I have 20 Celsius degrees. I'm going to multiply that by, look, my ratio. Celsius degrees is on the bottom, so it will cancel out. So it cancels right out. Fahrenheit degrees is on the top, so that's what I end up with. So what do I do mathematically? 20 times 1.8 is going to give you 36 Fahrenheit degrees. Now, that wraps up temperature difference. Hopefully that made it a little bit more understandable so that you can do your worksheet. Have a good day.